Okay, so good afternoon, everybody. Welcome to this webinar. Today, I just want to make 2 points. We will record this session for later viewing, and if you have to leave early or you want to show it to somebody else, then we will record it. It will become available on our website. And the other point that I want to make is that in the bar below, there is a Q&A session. And there you can type any question that comes up during the webinar. We will try to answer as many in the end, depending, of course, on how many questions we get. If there are too many to answer, then we'll send an email anyway, where we answer all the questions that came up during the webinar. So today we have our speaker, Steffen van Heijningen. Steffen graduated as a master in biology at the University of Groningen. He followed that up with a PhD in behavioral neuroscience, also at the University of Groningen. And his thesis is titled The Driving Force of Metabolic Programming. And he will be submitting his thesis this month, and he will probably do his defense later this year or beginning of next year. Currently, he's now working for Noldus as one of our marketing communication specialists. And during this webinar, he will talk about the individual versus social housing of mice and how the choice between these housing conditions can greatly impact your research. So, Steffen, the floor is yours.
Thank you very much, Renko, for this nice introduction. So good afternoon, or good morning for the ones joining in from a US time zone. So indeed, today I'm going to talk about this dilemma of individually or socially housing mice, because I came across this problem actually while doing my PhD research. So to talk a little bit about who am I, Steffen van Heijningen. Renko already gave a short introduction. So I studied at the University of Groningen, and I'm submitting my thesis, The Driving Forces of Metabolic Programming. So this title does not entail anything about housing conditions, but I assure you that this was a very important part of finding the appropriate models to work with. So in 2010, I started at the University of Groningen until 2015 as a bachelor and then master student. And then from 2015 onwards, I started working together with nutritional research in the Netherlands, working together on a PhD project about metabolic programming. And then in July, I started at Noldus, working as a marketing communication specialist. So contributing to a lot of the neuroscience content that we communicate. So the driving forces of metabolic programming. We all know that obesity is a global epidemic. So there's a lot of research about it. It has a lot of media coverage. This is not a new thing. What we try to investigate is obesity preventable? Is there a reason for obesity predisposition, and how could we be able to prevent this? For example, early life nutritional interventions. This is based on environmental factors, and of which the first environmental factors actually take place in utero. So these conditions in utero are obviously influenced by the health of the mother, of the diet of the mother. And you can imagine that the brain and the body are developed in utero. Thus, we need to provide the most optimal building blocks for a healthy development for later in life as well. After birth, we have nutrient transfer through breastfeeding. And again, the breastfeeding is also influenced by the diet of the mother. But obviously, we also have a difference in bottle feeding versus breastfeeding after birth. If we talk about nutritional quality and nutritional quantity. So this environment during the nutritional environment in the first 1,000 days of life has been dubbed as well, we have the term for this. It's called early life nutritional programming. And as I said, this is purely about providing these building blocks and using this early life as a window of opportunity to well, to study this transition from early to adult life. So this was a bit of the background on the topic of my research. But what I needed to do is I needed to search for an appropriate obesity model. So this was one of the main goals: investigate whether we can sort of model this obesity predisposition, and then afterwards prevent it with dietary intervention. So we have a very clear obesity model, of course, which is the Western style diet, also known as sort of McDonald's diet, if we use it in other terms. But we also looked at individual housing as an obesity model, and we incorporated a small litter rearing approach. For this presentation, obviously, I'm going to focus on this individual housing paradigm and the problems that also the very interesting things that I ran into. So mice as a model organism are obviously widely used in biomedical research because of their high similarity with the human genome, as expressed in this nice graphic. Easy to take care of. You can breed them in large numbers, relatively cheap. And the most used strain in this case, sometimes even called the wild type strain, is the C57 black 6 mouse, the very recognizable black mouse we see a lot. Why did I specifically use this strain of mice? And this is very important, again, for the background of my work if we talk about the early life nutritional programming. So in metabolic studies in general, it's a very established model. They're very obesity prone. And obviously we build upon earlier studies that were done in this context. So during the first 3 weeks of life, there is a postnatal leptin surge that takes place in these mice that play a role in the generation of hypothalamic feeding circuits. So this is work that was done, very important work by Sebastian Bourret. And you can see this in these graphics on the right here, where on the top in these images of graphic B, these are wild type mice, and you can see the formation of these fibers. You can see in the hypothalamus with increasing age. So P10 stands for postnatal day 10, postnatal day 16, postnatal day 60, which is adult age. And then on the bottom here, we have the leptin deficient mice, so the OB mice, very popular model, obesity model to use. So without this leptin surge, we see that there's actually a lack in the formation of these fibers, which you can quantitatively see in these graphs below. You can see the fiber density, and then the wild types at the young age, and then at P16, wild types versus the OB mice, and then again at P60. So this postnatal leptin surge is extremely critical in the formation of these feeding circuits. So these are projections from the arcuate nucleus to the hypothalamus, which are formed. In humans, this does not occur. You can see elevated leptin levels at the end of the prenatal period, which then decline quickly after birth. What that gives us is basically a postnatal model in mice in which we can study this hypothalamic feeding circuitry, which relates to a prenatal period in humans. So it creates an enormously interesting window of opportunity for us to do interventions and to do research into these feeding circuits. So this was obviously also one of the main reasons why we use this model in my research. However, in metabolic studies, we often run into the problem with C57 black 6 mice that we have to house them individually. We want to know food intake, we want to know water intake, we want to know energy expenditure, we want to collect feces. These are all things, for practical purposes, but also if we want to automate specific measurements, which can be challenging if we use, for example, socially housed mice, to be able to track these individuals in the cage. So metabolic studies often opted for the individual housing of mice. This can, however, influence the outcome past the point of being of it being a relevant model. And this is why I talk about this dilemma of individual for social housing in this webinar, because I was really doing obesity research, but I saw that the model itself was really affecting the outcome. So even in terms of intrinsic behavior and primarily the metabolic and physiological parameters. So let's talk about those for a minute here. Basically, social isolation is considered a stimulus for condition, which can lead to boredom and which can lead to an increase in reward sensitivity. So these animals become extremely sensitive to any form of reward. You can think of the Western style diets that I mentioned at the beginning as well, increasing food intake. Furthermore, because of this deprivation of social cues, for example, social facilitation, there's less feeding competition. The social status is completely different. This changes the energy use because these individual animals do not have to expend the energy into, social behaviors, interacting with the cage mates, etc. And then it also changes the energy availability because of the lack of the competition there is in obtaining food in just general feeding behavior. Additionally, it is already known also that sustained social deprivation may provoke chronic emotional stress affecting neuroendocrine immune axes, which can also lead to alterations in body weight and fat deposition. So this model itself, which we also try to use as an obesity model, does have its implications downstream. And this was reviewed in this review by Schipper et al. It's a very complex figure, so you definitely don't have to understand it all. But the general message here is that because of this individual housing, you're actually messing around with a lot of factors that influence this metabolic profile, also down to a behavioral level at the end. But this is an interesting review to also look at. And the main author, Liedewij Schipper, she was my supervisor at Nutrition Research. So I worked very closely with her on this project. We translated this into into one of my first chapters, of my thesis, which we already published in +1, which is titled "Individual Housing of Male Black 6 Mice After Weaning Impairs Growth and Predisposes for Obesity," where we're going to show what I just said before, the theoretical things about it. We're going to show some of the results. So here you can see this paper. So at the top you have the title and the author, so you can look this up for yourself. Graph A shows adolescent growth. This is from postnatal day 21 to postnatal day 42. So this is directly after weaning. And at the point of weaning at postnatal day 21, these animals are put from their nest situation into either an isolated state, so individual housing, or social housing, which is pairwise in this case, so 2 mice in a cage. You can see that these social animals gain more weight towards postnatal day 42, which we use as a cutoff point for adulthood. We transition the animals onto an adult diet at that stage, and we consider them as young adults, basically. So there's a definite difference between the socially and individually housed mice in terms of body weight accumulation, which we in this stage still call growth. Then if we switch over to adulthood, postnatal day 42 to 126, you can see that we also expose them to a Western style diet. But irrespective of this diet, these individual animals from this point on actually gained more weight. So this graph shows body weight gain. Earlier in life, adolescence, it impairs growth, but later in life, you can see that they actually try to, well, that's the hypothesis, try to catch up and add more weight compared to these social animals. Then if we look into these graphs, we show a bit of information on body composition. So we have lean body mass, we have fat mass, and we have femur length. Femur length is a very robust parameter for overall development, overall lean mass development, also for growth length of the mouse. We can see that the fat mass and the top graphs here are adolescents. And if we look at the previous graph, where we see that yes, the social animals here weigh more than individual animals. Their fat mass is significantly less. So we have a big difference in body weight, but the body composition is completely switched around in this case, really, leaning towards a obesogenic phenotype, which is still present in adulthood and possibly driven by this femur length difference, also higher in social animals compared to individual animals in adolescence and in adulthood, irrespective of the diet that they have been given. So this was obviously a very interesting finding, really proving that the body composition is completely switched around in these two housing conditions. We hypothesized in this slide, you can see some data on UCP1. We hypothesized that there is an effect of thermogenesis. UCP1 is uncoupling protein 1, and this is responsible for the heat generation in the brown adipose tissue. And this is considered as healthy fat. Babies have a lot of brown adipose tissue, for example. So we thought these individual animals are also less capable of keeping each other warm through huddling behavior and cage mates. So we did see some differences here, but it tends to be a different pattern if we look at adolescent versus adult mice. Where in adolescent mice, we indeed have a higher activity in the brown adipose tissue in individually housed animals. So that would sort of confirm that theory, but we don't see that in adulthood. But then if we look at the activity in the white adipose tissue of UCP1, which is also called browning of the white adipose tissue, we see that the effect is largest there in adulthood, where indeed these individual animals try to compensate a bit for that activity, perhaps due to this lack of social thermoregulation. So to summarize the main findings of this article, individual housing impairs growth during adolescence, but leads to increased body weight gain during adulthood, regardless of diet, leading to an obesity-like phenotype, possibly also due to a thermogenic strain because of this lack of this cage mate based on the UCP1 results. We took these results and we went on with our next study, which is chapter 3 of my thesis, where we used this model, individual versus social again, and then exposed them to an early life diet. Where in this case, we did got this validation of this phenotype in terms of obesity, but now we also added behavior to the equation. Because we wanted to see, is their behavior also changing because of this housing condition? We can see that in the top left, we have a nice effect considering distance moved in an open field. This is something we also know from literature, that they get that individually housed animals get hyperactive in a novel arena. So that's a nice confirmation. But also, if we look at an elevated plus maze, where we study anxiety-like behavior, you can see that the adolescent individually housed animals have a higher open arm ratio as well as the adult animals, which is interesting because we actually hypothesized that these individually housed animals, because they are socially deprived, would show higher stress levels, but an open arm ratio on the elevated plus maze indicates that they have lower anxiety-like behavior. So we were thinking about how this would come about, why we were seeing this different pattern, and we took that a bit further, and we looked into with my next chapter into how social housing actually affects specific behavioral outcomes. So switching now the focus a bit to the social housing condition. And the reason why we did this is this center graph particularly is again the elevated plus maze, but now we separated the socially housed animals into a group that was tested first and a group that was tested second. And this is because we test the animals in a consecutive order. So the results that we found before in socially housed animals, we thought were actually influenced by the fact that they were separated from their cage mate. Yes, you can say that individual housing brings about probably behavioral consequences or because of the deprivation of social interaction. However, if you expose these social animals that are used to being housed together to a sudden environment where they are separated, this can also induce stress. And this was also affected by their by the hierarchical status within the cage. So whether they were the dominant animal or the subordinate animal. So we tested this by doing a troop test to see which one was dominant in the cage. So this was a very important finding for us as well, which also led us to refine our methods of how we study or how we perform these behavioral tests in terms of habituation. And also if you have social animals, habituate them to a state first where they're used to being alone, and then subject them to the testing arena itself. Well, yeah, this is what I basically just explained. So the main findings of these two chapters were the validation of the obesity phenotype with individual housing. We kept finding this phenotype, so I won't show the graphs each time because we clearly see individual housing leads to increase in body weight and fat mass. And in terms of behavior, the most important thing that you should take away from this is that you cannot compare individually housed mice versus socially housed mice due to these large variations in behavioral response. Testing order affects this, and the hierarchy in social cages, and probably other factors as well. So that is something that you should keep in mind when designing your study and thinking about how you actually, when you're in the testing room, how you perform the studies. And to my surprise, I was looking up some literature about this, but it's really hard to find detailed articles of people looking into this. So these are two examples that I highlight, although they are in other strains of mice, which I indicate on the slide. I find it hard to really find papers on things like testing order and how this can obscure your results. So, but it's nonetheless extremely important to keep considering, especially if we look at social lives of mice. Mice are social species. They, they state that they should be group housed as long as the groups are stable, of course, because it is vital to the welfare because of multiple, benefits, which on an evolutionary level benefits to the survival of the individual, lowering predation risk and reducing energy costs via the social thermoregulation, which we talked about before. And this is people in terms of welfare lean towards the social housing, but this is where the dilemma, that's where my title of my presentation comes into play a bit. So, but if we look at the social guidelines based, this is the guide for the care of laboratory animals of the National Research Council. They state that housing should be based on the natural living conditions of the species. So, and also that this home cage should be an environment that provides for the animal's physiological and ecological needs. Again, going back to that statement that I made about being a gregarious species. So they will better cope with stressful procedures and your experimental results will be more reliable. But we run into this dilemma, and this is very nicely explained in this article actually that I found, to group or not to group. And this paper basically states a few things here, that they do focus on male mice. I have tested both sexes in my experiments, although I do not show data on this. But male mice naturally do not share, they do live in groups. However, they are very territorial, and aggression towards each other can be a serious problem, which affects the welfare of these animals. And this can even more negatively impact your animals in terms of stress. If you look at social defeat, for example, social defeat is an extremely stressful model. And this can happen in a home cage situation if you have multiple male mice that are, aggressing towards each other, and there's one consecutive mouse or more consecutive mouse that keeps losing in the social defeat paradigm. So, but they also state, this paper, individual housing may not be an appropriate solution, giving the welfare implications associated with no social contact. This is exactly why I titled this presentation "The Dilemma of Individual versus Social Housing." Like, what should we opt for then? What is then the most optimal solution? Because there are a lot of factors that influence behavior. We have handling, for example, tail or tube handling, which can affect behavior. So I tested both of these methods in my research as well to see if they indeed get less stressful if you handle them with a tunnel or a tube. Habituation is an important thing that we talked about. Also considering separation from the cage mate, that we can also choose to separate these social animals before subjecting them to a test in which they have to perform on an individual level. Even the researcher itself can influence this factor. So this is always a topic that keeps coming back. Try to control the variables, try to make it a level playing field as much as possible. If we focus a bit more on the separation from the cage mate, because this was something that was very interesting for me to investigate, we know that social isolation induces anxiety-like behavior. In terms of individual housing, how I did it for long term. So are these animals better coping with this isolation compared to the always socially housed animals? This could be the case. If you look at this study, however, they saw that they have an isolated group, which is so the first one is a control group and the third bar is an isolated group. They checked this over a longer period of time. So they indeed see, if we look at time in the center zone of an open field, that also long-term isolation can lead to increased anxiety-like behavior. Furthermore, on a neural level, we see that it can not only induce anxiety-like behavior, but decrease BDNF levels as well, greatly affecting neuroplasticity in these animals. Thus also, if we take apart the metabolic side of the story, could also affect cognition. Now, what's my answer on should we house mice individually or socially? Because the discussion goes from one point to another, and I've also noticed that when giving similar presentations. Yes, social housing is more naturally relevant. And yes, individual housing does cause depressive-like phenotype, leading to body weight and fat increase. Social housing increases some logistical challenges in terms of identification of the mouse. We have hierarchy, we have testing order effects for which you then all have to try and control for with habituation methods. However, yeah, individual housing is inevitable in some cases. Think about cannulas, implants, we talked about fighting behavior, and also metabolic cages in which we want to know the exact energy expenditure of one mouse instead of an entire cage. My approach to this is actually pragmatism. Pragmatism is key in choosing your preferred way of housing, because that's what it comes down to. There is no perfect way, but it should be tailored to what you need for your research. So use concepts from other studies or previous studies, similar studies, and learn from those previous experience, like I showed you in this presentation, and make sure that then you take those things into account when going for your model of choice. And also a very pragmatic point is consider what you actually need from your data. For example, food intake. I've thought about this point for a long time in my studies. I wanted to know food intake constantly of my animals, but was it really of such an added value that I needed it from individual mice, or could I just take the cages as a statistical unit? And the latter is exactly what I did in my previous study. And I was also privileged to be able to use a high N because of how I designed my studies. So I didn't have any big large interventions or anything. It was only dietary interventions, so I could, have a high number of animals, so I could still retain this statistical power when only opting for using cages as statistical units. But still, it's always good to stand still with what do I actually need? Is this, can I in some different form of analyzing this, or still by grouping this data get the information that I'm actually looking for to be able to accurately test my hypothesis. And then, considering all these other effects like testing order effects, counterbalancing, habituating, testing during rest and active phase. Make sure you check everything beforehand, that everything is the same and no errors can be made. So I had a lot of students working with me, a lot of interns on these projects, and things like rest and active phase testing was a constant discussion because of the times at which they wanted to work or do the project. And it was my job to really keep in check, like, okay, we have to do this in a very similar way, and also not doing too many animals on one day, that the first animal is tested at the beginning of the day and the last animal is tested at the end of the day, for example. So, but these are all things that you've probably heard about, but it accumulates all these factors that you have to take into account. So it's always good to make a list. So how can Noldus help actually in this whole topic? And we're talking about this entire topic of my webinar here. And I get the question a lot, and obviously my PhD defense is coming up. If I would do it again, what would I change? What would I do differently, or what would I do in the future? And I would set up my research for continuous monitoring with the Noldus phenotyper. The reason for this is that I really miss a full metabolic, behavioral, and activity profile on these effects of social versus individual housing. These things like huddling behavior, social behavior, but that's primarily eating, drinking, and activity patterns, is something that I just need to increase my resolution on. I have these small snippets within their development, which simply do not give me enough insight in how these metabolic profiles are being built up. If we look at an illustration of this, this is how I depict the entire timeline of the development of one of my mice, for example. And the snippets, what I'm talking about is, for example, here we have some behavioral tests, and here I measure for a few days energy expenditure, for example, in an indirect calorimetry setup. But with using Noldus phenotyper, I could actually really, that's what I mean with increasing the resolution, really increase these these time frames in which I measure things. So gathering a large amount of information actually from a very powerful setup. So that would be my answer to, if I would do this again, how would I approach this? I've come to the end of my part. So for any questions, you can always email me. You can always contact me at this email address, steffen.vanheijningen@noldus.nl. And I would like to thank you for joining in, and I would be happy to answer some of your questions. So I give the floor back to you, Renko.
Yeah, so thank you, Steffen, for this excellent webinar. We have a few questions that came in, and one of them is also in line with the question that I wanted to ask. But this one is from Margayata. Sorry if I pronounce it wrong. So what she wants to know is, please indicate the group size, which is crucial for interpreting the graphs in the first part of your talk. And yes. My question, which is a little bit related to that, is like, when is something considered a social housing? Is that 2 animals? Is that 10 animals? Or
So yeah, the term that I use, social housing, in this case could be a bit misleading, because I try to keep it simple in my case, because I wanted to test a condition of 1 mouse versus 2 mice in a cage. Because if you add even more, if we talk about hierarchical structures, it gets even more complex. So it's really a terminology thing. It's more appropriate to call it pairwise housing in my case, but you consider it social housing. In my case, more than 1 mouse per cage.
Okay, and the second question is also from the same person, and that is, in the first part of your talk, what was the gender of the animals? And if you have any notes on the susceptibility of female mice in social isolation.
Yeah, so the gender I talk about male mice in my results in this case primarily, and this is because in the first few experiments we only applied for male mice, and then in my final experiment I wanted to look at the sex differences as well, but I didn't include these behavioral profiles in my thesis because I focused on the metabolism. So any notes, so all the results you saw were of male mice. But any notes on female mice is what is interesting is that they do show a different response to this social isolation. Basically, the obesity-like phenotype that we see in these male individually housed mice, the females are less susceptible to this. And I don't have enough information to explain as to why. And I know that also the social structures in socially housed females are also different, but they do not gain as much body weight and fat when individually housed from weaning as the males do. So if they are less susceptible to stress, that I do not have the answer to, but they definitely do have different phenotype.
Okay, and there's another question from Julia Odermatt. Did you observe a difference in the behavior of the mice when they were handled by the female or the male researcher?
Oof, yeah, that would be a very interesting thing to look at. Actually, we did have different gender researchers, but yeah, so this is something that we haven't quantified. Basically, so this is exactly what I talk about when I'm increasing resolution, and this is not only done with phenotyper, of course, but all these things that I talk about, like how you handle your mice and how you control for specific things, are often overlooked. So I think we can gain a lot of information from, well, exactly your question. Do these mice respond differently? So yeah, that would be my answer. It's a very nice suggestion, but it's a lot of work, quantifying this. Sometimes I work with large groups, a lot of animals, so logistics is obviously an issue there.
Okay, and then we have another question from Stephanie Marseille. Can a reversed cycle also affect society?
I guess with a reversed cycle, we're talking about the light-dark cycle.
Yeah, it's not mentioned like that, so maybe we can answer that via email. That might be a better way, just to get a understanding of what exactly is meant. Is it for a reverse cycle for the animal or for the researcher?
Yeah, I think I suspect that it's about a reversed light-dark cycle, and it can definitely affect anxiety. But this is also why I tested the mice in a light condition, because if I have bad experience with testing in a dark condition with entering the room, for example. If we look at anxiety tests, there's a high chance of sort of polluting your testing area with light distribution. And I'm not a fan of working under red light conditions because it's difficult to see. But yeah, the opinions are really spread out about that. What is the best way to test in light or in dark? So that's rest or active phase for the mice respectively. So yeah, but I didn't test that.
Okay, and then we have a last question which came in via the chat. So I would like to ask Mark to also put it in Q&A, so it's saved after the meeting. I cannot do it for you. And his question is, shouldn't the first and second tested bias disappear with handling the mice, given you handle them one after each other?
Yeah, the handling is really important here. And I think the difference here is not that we handle them differently, but it's the time that they have to wait in sort of their home cage before their cage weight is done with the test. And I think this separation induces a stress in both the first and the second tested mouse, of course, because one of your cage mates just disappeared. So you can imagine that this could be a stressful situation for these animals. In terms of handling, could this be avoided? That's how I interpret the question, by sort of control handling these mice. That is not exactly what we did in our last experiment, but we tried to approach that by first separating them into a different cage. It did have home cage bedding, and then afterwards subjecting them to the test. And we did see, well, we actually didn't see this testing order effect anymore. So, but we didn't have a control condition for that, considering like that we do a habituation like that, and we don't do a habituation. I just incorporated it in my design altogether.
Okay. And then we have a very nice question from David, and he's not familiar with the plastic cup handling. So if you could explain a little bit more how that works. And
yeah, so that's a very good question, and it's actually a very relevant topic. So it's not a plastic cup, it's more of a tunnel or a tube, which I placed in the cage as cage enrichment, actually. So extra cage enrichments aside from any housing or bedding material. And the mice get very used to this tube also because it's in the home cage, obviously. But the tail suspension, or picking up by the tail, is actually considered stressful for the mice as well. You know, all their weight is hanging on this point. They can handle it, but in practice, you know, if you misgrab, or you know, if the mice runs away, you try to grab it really quickly, it can induce stress. So what I did is I use this tube, and I just when it's in the cage, when I go weigh them or something, I just grab the tube, and they have to get used to this. But after a while, they just walk into this tube. You carry it over to your weighing station, for example. They walk out of the tube again, you weigh them, and then, you know, the same thing in reverse. So you can find it under research if you Google for or PubMed for, you know, tunnel handling or tube handling of mice. So there's a lot of research popping up on how this benefits the stress levels or anxiety levels of your mice. So it's definitely worth to check that out if you're looking at refining the handling of your mice.
Okay, so I just want to stress that all the questions that are being answered, we will answer them later on in an email to everybody. But I think we have a little bit more time to do just one or two extra, if that's okay with you.
Yeah, for me, it's fine.
Okay, so Raj has a question also concerning the light-dark cycle. Did you use a reverse light-dark cycle or just a normal one?
Just a normal light-dark cycle. So during our light hours, it was also light in the rooms, and this was purely for logistics, because we found it very difficult to keep working in these dark conditions, since we also had a lot of mice to take care of and a lot of handling to do. So this is a discussion that always pops up in our department as well. Like, do you do the testing in the dark phase, or do you have a reverse light dark cycle? Yeah, what I said, because of really logistical reasons, we opted for normal light dark cycle. Starting at around 8 in the morning, the lights went on.
Okay, so there's another question now from Jeffrey Alexander Jimenez. And it's regarding the anxiety levels. Do you think the anxiety level we find in mice that are singly housed is equivalent to the level of anxiety that we find in a submissive mouse that is paired with a dominant mouse?
So if the anxiety level of an individual mouse, you mean, is equivalent to a subordinate mouse?
Yeah.
I wouldn't know, actually. I could go back to one of my slides about this, where I looked at these differences, and we can try to find an answer on this. So what I found in general is that socially housed mice showed higher anxiety-like behavior because of a lower open arm ratio. And what I saw is that this only gets, if we include this testing order, it only gets stronger if you add this hierarchy factor, so in subordinate animals. So I would guess that subordinate animals are more susceptible to this separation anxiety, separation from the cage mates. And where in my first experiment in individually housed animals, we saw a lower anxiety-like, with our lower anxiety-like behavior, I think is really related to this separation. And so I think, yeah, I'm not sure if they compare. If you look at these levels, they do seem to be around the same level here. But here we didn't find this individual versus this pairwise difference. So that was really the previous experiment. So that's the only thing I could say about it for now, that I do think there's a higher vulnerability in subordinate animals to experience a stressor like this.
Thank you very much. For the people who attended, I just want to stress that we recorded this webinar. And if you want to look at a certain slide again or the entire presentation, then you can go to the website in a few days, and there you can see the entire webinar again. For the people who answered questions and for everybody attending, we will send them like a more detailed answer in the coming days also. So I would like to thank everybody for attending, and especially Steffen for presenting today. And then that's the end of the webinar.
Yeah, thank you all for attending and for the nice questions. Thank you, Renko, for hosting.
No problem.